So hello everyone, in this video we will be solving another LeetCode problem, and the problem name is count negative numbers in a sorted matrix. So given a m cross n matrix grid which is sorted in non-increasing order both row wise and column wise, you need to return the number of negative numbers present in the grid. So the problem statement is pretty much simple. You just need to count the number of negative numbers that are present in the grid which is row wise and column wise sorted. So how we will be able to solve this problem? Let us see. So I'll be showing you three approaches. One will be the brute force approach, second will be the better approach, and the third will be the most optimal approach. I'll share you the code of the most optimal approach as well, but yeah, I'll tell you all the three approaches as well. So what is the first example? So let me just draw the grid. So yeah, this is the first example that we are taking. So first approach would be the brute force approach. So in the brute force approach, what you can do, you can, for every row you can iterate on each and every column and just check what all negative numbers are present. So for first row you will check all the columns, for second row you will check all the columns, for third row you will check all the columns, and for the fourth row you will check all the columns. So this solution will get accepted in the brute force also because the constraints are very low. So the brute force time complexity will be nothing but big O of m cross n. But we will not learn this solution, or we will not use this solution. We want the most optimal approach. So before showing you the most optimal approach, I would like you to show the better approach as well, which uses binary search. So better approach is the binary search. I'm just writing BS, binary search. So yeah, so in the binary search, what you can do, so if you observe it carefully, we just need to find the first negative number. We just need to find the first negative number in each and every row. If we are able to find the first negative number, the rest, all the numbers that are right to it, will obviously be the negative numbers because it is in sorted order. So if you see here, if we find this first negative number, all the elements to its right are negative. If you see this particular row, if you find this first negative number, all the numbers that are right to it are negative. So we just need to check in each and every row what is the first negative number. If we are able to get the first negative number, we can just take all the elements to its right and add it to our answer. So what you can do, for each and every row, apply binary search in order to get the first negative number. And yeah, if you get the position of that, just add all the elements including that particular number towards the right of it to your answer. So for example, for this row you get this is the index x 0 1 2 3. So this is the first negative number you get. The total elements present in each row is 4. So let's say 4 is the total number of elements that are present in each and every row. So you find in the first row what is the first index where we find the negative number. So this is the index, 3 is the index. So we, including this particular number and all the elements towards its right, you will add it to your answer. So you will add what? You will add n minus c, or n minus index to your answer. N is the number of columns. So for this particular row there will be 1 2 3 4 elements present. For second row also there will be 4 elements. So this is what this n is denoting, the number of columns. That means how many elements are present in each and every row. So n minus the index of the first negative number, index of first negative number. So 3 is the index of first negative number. So you add what? Add 4 minus 3 to your answer. So your answer becomes 1 for now. And yes, it is correct. For this particular row there is only one negative element present. So you move in the next row. You again apply binary search and you find out what is the first index where you are finding the negative number. So you again get the index as 3. So you will add again 4 minus 3 to your answer. So your answer becomes 2. Then you come on to this 0, 1 and 2, this second row. So you again find, with the help of binary search, what is the first negative number, index. So you find the index is 2. So you again apply answer plus equal to n minus idx. Idx in this case is what? Idx is 2. So you add 4 minus 2 to your answer. So your answer will become 1 plus 1 plus 2. And if you see in this row there are two negative elements present. So yes, till now we are getting the correct solution. Now you come at this particular row, that is the third row. Now you again apply the binary search on this row to find the first negative element. You find, okay, at 0th index we have the negative element, so you add what? In the answer, n minus idx. Idx in this case is 0 and n will remain 4. So answer will be in this case 4. So you add 4 to your answer. So in total, how many negative numbers are present in our grid? 1 plus 2, 2, 2 plus 2, 4, 4 plus 4, 8. And if you look at this particular grid, there are 8 negative numbers present. 1, 2, 3, 4, 5, 6, 7 and 8. So yes, with the help of binary search, we are able to get the correct answer. But this is also not optimal approach, because here we are utilizing the concept of column wise sorted matrix but not utilizing the row wise sorted matrix. So its time complexity will be what? Big O of m cross log n. Why? Because for each and every row we are applying binary search on column, and the time complexity of binary search is what? Log of n, and n is the number of column because we are applying on columns, and for each and every row we are doing, so we are just multiplying by m, because m is the number of rows. So m cross log of n is the time complexity for the binary search approach. So this is also not the most optimal approach. Now I'll tell you what is the most optimal approach. So yeah, now I'll tell you the most optimal approach. So this is the most optimal approach by which we'll be solving this problem. So what you will do, you will declare two variables, row and column, and you will initialize it to row equal to m minus 1 and column you will initialize to 0. Now in this approach we will be utilizing both the things, row wise and column wise sorted things. Then only we will be able to get the most optimal approach. So you will initialize your pointers to row equal to m minus 1 and column equal to 0. So I'll just name the index 0, 1, 2, 3, and here also 0, 1, 2 and 3. So for each and every iteration you will check whether this current number is positive or negative. If it is negative, what you will do? So let me just write also here side by side what we are doing. If grid of row comma column is negative, that means all the elements including this particular number towards its right all will be negative, because it is sorted, it is in sorted order. So what you will do, you will just add answer plus equal to n minus the current column. This is the index. The same thing that we are doing in the binary search approach, just same. But here after this you will also decrement your row minus minus, because for this particular column, for this particular row you have find all the negative numbers. Now you need to find for the next row or the previous row or the row just above it. So you will decrement your row minus minus. But what if this element is positive? Now I am just writing the code. I'll explain the dry run as well, how it is working, then you will understand in more better way. Now if this particular grid of row comma column is positive, in that case what you will do, you will just increment your column pointer. Now why? I'll just show you with the help of dry run. You will automatically understand why we are doing this. Now this is the so let me just keep the answer variable as well, which will be currently 0. So this is a negative number. Our current row is 3 and current column is 0. So this is the negative number. Okay. So all the elements including itself towards its right will all be negative because it is in the sorted order. So you will add n minus column to your answer. So n is 4, column is 0. So you will add 4 to your answer. So your current answer will become 4. Now for this row you have computed all the negative numbers. So just move your row pointer ahead, keeping the column pointer same. Why? Because it is in the sorted order. So obviously there might be a scenario that we find the next negative number here only. We might not find. So in that case only we will be moving our column pointer ahead, because we don't know. There is still possibility that we can find the same we can find the negative number here only at this 0th location. So that's why we are not incrementing the column pointer here. We are incrementing the column pointer only when we do not find the negative number. So in this case this particular number is not a negative number. So that means for this column we will not be having a negative number because this is in the sorted order and this is also in the sorted order. So if this is not negative, then obviously we need to move in the right direction to find the first negative. So that's why we are doing column plus plus. So now our column pointer will be here. Now you will again check if this current grid of row comma col is negative or positive. You again got it positive. So for this row we do not find negative number till now. So again you will do column plus plus. So now we are here. So okay, for this particular row, this is the first index where we find the negative number. So you add n minus column to your answer and you go to the next row. So here n will be 4 obviously, and your column will be 2 because we are standing at the column 2. So you add 2 to your answer. So your new answer will become 6. Now your column will be remaining here only. Why we are not starting from 0 again? Because there is no sense, because this is already in the sorted order. So for this row, if we didn't find at 0th and 1 index for the column the negative numbers, then obviously for this scenario also will not be finding the negative numbers because it is in the sorted order. So that's why we will not reset our column to 0. We'll keep our column pointer as it is. Now our row will be pointing to the first index. So again we will check in this particular row what is the first negative number. So our column is here, column is at 2 and our row is at 1. So this is the number that we are currently at. So this is positive, so we'll move our column pointer ahead. So now our column will be here. So yes, this is the negative number. So just add n minus 3 to your answer. So that is nothing but 4 minus 3, 1. So you add 1 to your answer. So answer is 7. Now you will again move your row minus minus. So your row will be pointing to here. Now again you will check whether this particular number is negative or not. Yes, this is negative. So again add n minus column to your answer. So it is again 1. So you add 1 to your 7. So your answer becomes 8. And yes, this is the correct answer because there are 8 negative elements. That is 1, 2, sorry for that, not this, 3, 4, 5, 6, 7 and 8. So yes, we are getting the correct answer. So let me just summarize what we are doing here so that you can have a better understanding. So let me just read out this entire thing again for you. So yeah, what we are doing, I am just summarizing the entire thing for you once again so that you can have a better understanding. So we are initializing a row and column pointer, row to m minus 1 and column to 0. That is this particular cell. We are initializing from here. Now we will be having two scenarios. Either for this row, to calculate the negative numbers, this particular number will be negative or it will be positive. If it is negative, then for sure all the elements towards its right will also be negative. So we'll just add n minus c to your answer, and for this row we have already find all the negative numbers, so you'll move to the next row to find the negative numbers for this particular row. So you are just doing r minus minus. So now your row will be here, but your column will remain same because we again have a possibility that at this particular column either this number can be positive or cannot be positive. So that's why we are not changing our column pointer at this position because we are not sure. It can be positive, it can be negative. So that's why. Now again, it can be positive or negative. In this case, it is positive. So that means if this is the positive number, that means we need to move towards right, because then only we'll be finding the negative number. Then to move towards right, what we can do, we can just increment a column pointer. So this is what we are doing. If the number is positive, just move your column pointer ahead to find the first negative number. Now this is also positive, so we are again moving the column pointer ahead to get the first negative number. So this is how we are doing. If the number is negative, just add the n minus c to your answer and move towards the next row. If the number is positive, that means you need to shift towards the right to find the first negative number for that particular row. To find the first negative number, you just need to move your column pointer ahead. So this is what we are doing. So I hope you understand this particular dry run part. So let me just show the code to you. You will understand in more better way. So yes, what we are doing, we are initializing n and m as grid size, and this is nothing but row and this is nothing but column. So yeah, the one thing that is different from the explanation is that I have swapped the n and m variable. In the explanation, I have taken m as the number of rows and n as the number of columns. Now in the code part I have swapped that. I have taken n as the number of row and m as the number of columns. So that doesn't matter, just change the variable names. So we are initializing row with n minus 1 and column to 0 and answer also initialized to 0. So we are iterating until we have row greater than equal to 0 and we are within the limits of the bound. So that is what we are doing. So we are keep on iterating. Now if the current number is negative, that means you just need to add m minus column to your answer and move towards the next row. Otherwise, if the number is positive, that means this is the positive number. So for this row, if this is positive, to get the negative number, you need to move towards right. So to move towards right, you will just increment your column pointer. So this is what we are doing. In the end, whatever the answer variable has the value, just return that. So this is how we are solving this problem. So I hope you understand this solution. Thank you for watching.